What's up guys? So today we're trying something a little new with my face cam. I figured I never look at the face cam anyways, so might as well have a little bit of a nicer background instead of looking at my white wall the whole time. Downside is Anakin won't be as much in the background going up and down the stairs, but actually you will catch him still going up and down in this corner, so not all is lost. Hey, there he is. He's hungry. He wants some food. Today we have a PS5 in for a HDMI port, and I figured I'd just go through and do like a full... Can I help you? I suppose I should go feed him. I'll be right back. It seems he'll make himself known regardless of where the camera is. Alright, so as I was gonna say, I figured I would just go through and do a in-depth guide for HDMI ports on the PS5. This PS5 is pretty messed up. There's also tape for some reason on the PS5. So let's at least take that off. We can see here that the port is in fact pretty damaged. I would say very likely more damaged on the board itself than it is inside. Hopefully we don't have any torn pads, but as far as I can see in the port, the pins are actually looking somewhat fine. It's really just the port that's bent. So hopefully we don't have too many ripped pads, but we'll see. Yeah, HDMI port repairs are a nice way to start getting into repairs and make some money with it if you just want to flip consoles and stuff like that. This is a nasty console, but for my birthday, my mom asked me what she could get me tool-wise, and I was never going to buy one of these for myself, but I keep seeing people using these for cleaning consoles, and I saw Soren cooling down the motherboards with these, and I thought that was genius. It's just a really high-powered blower in place of like compressed air, basically. So I think this is going to come in handy. I've already used it quite a lot more than I thought I was going to. But yeah, I'll throw a link for this in the description if you're interested. It also comes with a nice little bag and then some different attachments. I think we'll use this one right now just to blow all the dust out. So this is going to get pretty nasty. So let me just do this in the other direction. That was a horrible idea. Well, that made quick work of the dust at least, but it's all airborne now, which is kind of nasty. All right, so let's get these covers off. I will say this thing works really nice as a replacement for compressed air. I am absolutely loving this thing. Made quick work of all that dust. I'll do a very quick sort of overview for a teardown of these. They're not all the same. There is different revisions. You can also tell if this is like this, that the PlayStation hasn't ever been opened. This is like a warranty sticker. You can see when you peel up on it, it can't be put back without showing the little PlayStation icons on there. So there's the warranty sticker. Fortunately, we have a console that no one's worked on before. These little triangles indicate which types of screws go where. So all of these black triangles here with nothing in the middle are the same type of screw. They're sort of the shorter threaded screws like that. And then you have this triangle that's just sort of outlined here. And this one is a little longer and thinner. So like this. And then it doesn't have an indicator, but on the two corners here, this corner and then this corner, you have a long threaded screw. So here are the really long threaded screws. And then you have this one here, which is sort of like a double triangle. This one is a bit longer, but it's not quite as long as the one in the corners. So just be aware of all the differences there. Use these to your advantage. We also have one here that's unmarked that is always really small. So it's the tiniest black screw. It's the only one and it goes here. Other than that, you also have these little silver screws, which you're going to get to know very well because there are a ton of them inside the console that we have to take out. So let's pop all these together here. And I just like to make a big bucket of those silver screws because we're going to have a ton of those. So I'm not going to bore you with this. I'm just going to go around and take all the screws out and we'll get into the console. More dust. These consoles are nasty. Some people ask me why I wear gloves. This is one of the main reasons, to be honest. Let me just blast this one more time with some. Man, this thing is filthy. All right, now we can just take a plastic spudger and just pull these antenna cables. I like to pull them from the actual metal part themselves, not the wire. You can accidentally rip those connectors off the wire. This connector is for the lights, the LEDs right here. And then this connector right here is for the power and eject buttons. This is the part where I always say I need to get an electric screwdriver, and I never do. But yeah, you got to take out all of these silver screws. All right, after giving yourself carpal tunnel by removing all of those screws, you're going to want to pull up on the metal gently and allow it to sort of separate. These little dots right here are over the VRAM, and here are over the SSD NAND chips, and there's a bunch of little thermal putty that you just need to separate gently. Just gonna pop that off. and we've got all those little thermal putty dots right here. So try not to get them dirty or mess around with them too much because we want to try to reuse those. And now we have this little connector down here that we can unplug. On some of the newer revisions, you can unplug that a bit sooner because there's just a little cover instead of the whole metal shield covering it. Make sure you don't strip these. Depending on the console revision, they can be a little bit more difficult to take out because there's a lot of pressure on them. We can gently separate this PCB now from the heatsink. Again, we're going to have a little bit of trouble doing this because there is some thermal putty and stuff holding the sandwich together. So you just have to gently pull up. Try not to flex the entire PCB too much. You can crack solder balls underneath the APU. So just be very gentle. We also want to unplug the board from the power supply here. So just pull up and separate the metal shielding and the board from the PSU. And just make your way around and carefully separate the motherboard from the heatsink. Eventually it will kind of all come loose like this. And be very careful to lift straight up and flip the board. Reason for this is you don't want to spread this liquid metal all over the board. You can see again the thermal putty being used on the board here, as well as on the NAND chips and the SSD controller here. We can also see the classic oxidation on the heatsink and on the APU. This is a very common occurrence on the PS5, and I'll show you how to go about fixing that later when we go to reassemble the console. But for now, all we need is this motherboard so that we can swap out this HDMI port. So I'm going to put the rest of the console aside, and we're just going to focus on the motherboard. So let's go under the microscope and see what kind of damage we have. And I can already see some loose pins. Looks like the entire port just sort of like pushed itself forwards on the inside. A lot of times on these PS5s, they don't use a lot of solder on the HDMI port, and it just kind of comes off like a Lego. I don't know why there's so little solder used on these. Oh, and this thing, just look at this. This thing is just completely loose. And then this pin here is the only thing that is like holding on for dear life. You can see this whole entire port just shifted forwards like this and knocked off this capacitor. So we're gonna have to replace this capacitor. But fortunately, I'm not seeing any ripped pads so far. And the ripped pads that I see are often just from people actually trying to repair their own console versus the port coming off and ripping the pads, because there's not enough solder to rip the pads off. It just comes off like a mega block. So maybe we'll be able to find the capacitor in the console somewhere, but I highly doubt that. In our case, I'll probably just pull it off of a donor. The other thing I would be worried about here is the potential for this port to short some pads and potentially cause issues with the encoder. So we may have to replace the encoder as well, but we'll see. We can still pop some low melt solder on there just to be safe. So mixing in low melt or leaded solder lowers the melting temperature of the unleaded solder on the board. Oh, and you can also see some strain on the PCB itself there. You see if I rock the port back and forth, you can see the cracked conformal coating and the ground plane there kind of pulling up a bit. Probably on the other side too. Yeah, look at that. You can see all the stress that was on this port. For HDMI ports, I actually really like using my Hakko iron because the iron tip is really large and transfers quite a lot of heat to the board. The C245 iron I have does get up to temperature, but I don't know, I find the Hakko to be a little bit more robust with the ground holes, especially HDMI ports on thick motherboards like this. Maybe what I'll do, since all of these other pins are already loose, I'll just add a little flux to that one leg there, that one remaining leg, and we'll just try to hit it with some low melt solder here really quick. This is way too much, so I'm just gonna clean off my iron tip a little bit because I don't really want that much. A little goes a long way with low melt. So you don't really have to do this, but the reason I like to add low melt to these pins is just to make sure the solder that's on the legs melts really fast when we apply hot air, so we don't risk ripping any pads. The low melt solder really melts at quite a low temperature. So we essentially just don't risk pulling those pads up whatsoever if we apply sufficient hot air to melt the ground holes. So for these ground holes, I like to use again my Hakko iron, and we're gonna set it to 425. We really need some high heat transfer to deal with these ground holes because they're thick. So I'll just apply a little bit of low melt to my iron here. And I'm also gonna use hot air to help heat up the metal on the port and the ground hole as well. So we're just gonna go up to 350 at like 60% airspeed here, and just get in and heat the port with both the iron and the hot air. And this will just really help the low melt solder travel through the board in that ground hole. So that should help a little bit. It's quite a lot of low melt solder, but that's fine. I'm just gonna try to pull some of that to use on the other legs. Can throw some flux there, and try to mix some in here as well. I just turn up the airspeed a little bit to like 75%. And you can see right there on the bottom left, it's mixing in and melting. I also just moved that resistor right there, so let's fix that. I didn't mean to do that. So we can snag this hot air here. And then we can throw some flux and reflow that. And there we go, that's fine. Cool, and I'll do these other two legs as well from this side, and then we'll go from the back. I'll note this is not at all a necessary step. You can just hit the port with hot air and get it off with factory unleaded in there, but it does help make the job a little bit easier if you mix in some low melt or some leaded solder. But yeah, it's by no means a necessary step here. I just like doing it. Cool. Take care when you're working on this not to like rest your hand on the liquid metal, because if you get it on your hands, you're gonna wipe it all over the board and cause shorts everywhere, so just be really careful. This stuff is conductive, so don't spread it around. And I just turned the board around because it helps with the angle that I'm soldering at. Always remember that you can always change the angle of the board, rotate the board to make your life easier. Don't just like work at an awkward angle. It's never worth it. All right, so I'm gonna flip the board here, and the nice part about this little power supply connector here is that it sort of separates the board from the table so that this liquid metal doesn't rub all around your table. So just make sure this is still on the table, and it will kind of keep things up at an angle here. All right, so we've got some other ground holes here. I'm just gonna grab this little foam thing here, and same deal here, we're just gonna mix in leaded solder. Be aware of those two little components there. You don't want to move those or mess with those. And same thing here, we're just going to hit it with some hot air. Cool, and whenever you're done with using low melt solder like that, you don't want to ever use that to actually solder anything onto the board, just because it has a really low melting temperature. So I always just like to mix in some leaded and clean like 3 or 4 times here, because we really just want to get all of that alloy off of our iron. Even just a tiny bit mixed in with other solder is no good for actually soldering stuff to the board. So just making sure to replace that all with some nice leaded solder here so that we don't accidentally put low melt solder where we don't want it. All right, now we can lay the board off of the edge of the table like this, and I'll move the fume extractor a little bit closer here. You're gonna remove the nozzle from your hot air station and set it to max airspeed. I almost always use max airspeed without the nozzle, because anything lower is generally not enough airspeed to transfer much heat without the restricted airflow like this. So we're going to come in at 400 degrees Celsius and just slowly heat up the port on the top and the bottom. Heating from both sides will make your life much easier. And then get yourself a pair of blunt tweezers or something that you can use to sort of rock the port gently back and forth with, and it should just pretty easily come off the board like that. And we'll just let the fume extractor cool the port, and then we can throw it in the trash. Cool, so I'm gonna throw that away now. And while we have this off the table, I have a new little solder sucker that I wanted to try. I had this one before, I don't remember where I got this. And this is literally the only thing I ever use this for, but mine's kind of crappy, so I just decided to pick up one that's a little bit nicer. It's from Relife. I'll have a link to this in the description if you're curious, but it's just like a nice aluminum one, which is just a little bit nicer quality. Oh yeah, much nicer. And it's nice and small too. This thing's huge. I'm not a big fan of the plastic tip on this. This has a nice like silicone tip. It feels super nice too, very satisfying. But let's see if it works well. That's what matters, right? You can also usually take these apart to clean them. I just want to make sure I can do that. Looks like it unscrews from this side. Got the spring. And then yeah, you can clean the inside of this here. And can you take this side off too to clean that? Just want to make sure you can clean both sides. Yeah, you can unscrew either end here. But yeah, it's important to be able to clean these because these get really nasty and then they don't provide nearly as much suction, so you got to take care of these things. So let's try this thing out. So the way I like to do this is just to use the nozzle on the hot air station like this. And we'll go back up to like, I don't know, 425, 75% airspeed, and I'll use my iron, and I'll use the hot air from the bottom and the soldering iron from the top. Just get these nice and melted, and then we can come in with the solder sucker. Oh, that works beautifully. I'm really happy with that. I really like the silicone tip on this because it provides a nice extra bit of suction. So I'll do the same thing over here, melt the top with the iron, bottom with the hot air station, and we'll pop these off. Easy. This is significantly better than my old one. So this is going in the trash, and we're gonna use this from now on for ports. And look how beautifully empty those ground holes are. No futzing around with a wick, no $400 desoldering gun, just some hot air and a solder sucker. Again, I have to say, like, I rarely use these things. The only time I use this is for this exact purpose. So I can't say I recommend grabbing one of these unless you're doing lots of port replacements. But I know some people don't clear these holes before replacing the port. I just like to replace it with leaded solder. Oh, and it looks like if you push a little farther with this, it kind of cleans itself. Like, it pushes the excess crap out of the tip, and you can also pull this silicone tip off, and I think they sell replacements for these. But you can see it does a nice job of pushing some of the crap back out, like flux and solder and stuff like that. So this is really nice. I like to clean these after every use, because when you want to go to use them, you don't want to have to clean it. When you don't clean them, the suction is just god awful on them and doesn't do anything. Alright, so now let's add a little bit of fresh flux on top of the pads here. And let's snag some of this off. And I'm going to tin my iron with leaded solder here. I'm just going to go over these pads without touching the actual pads with the iron too much. Just mix in the leaded. I want to make sure to add a little bit to that capacitor area there. Cool, that's looking great. And then cut a piece of wick that's somewhat small like this. Don't use it off the roll. You're going to have a little bit more trouble if you try to use it off of the roll or a long piece, because your soldering iron has to heat up the entire bit of wick that you're using in order to sufficiently wick without ripping up pads. This is where a lot of people rip pads, is by wicking incorrectly and not using sufficient heat. You actually do want a relatively high heat on your iron to transfer enough heat to the wick. And you also want to tin your iron a little bit with some solder, even though it sounds counterproductive, because the solder promotes heat transfer between your iron and the wick. So we're just going to go through, and we should grab this in one go. And you shouldn't get stuck at all on the pads or anything, just like that. That's all it needs. And I'm using 425 there on my iron. It's a little high, but it really does help to wick without causing any problems. So now I'm going to grab one of these foam cubes, actually. I really have found that I like these foam cubes for cleaning up large amounts of flux like this, when it's like a flat area and there's tons of flux that you need to clean up. These do a really great job cleaning them up. Otherwise, I'm going to use like 4 or 5 Q-tips or a few different wipes. But these sponges do a great job cleaning up like a lot of flux on the board. That's really what I found them useful for. I haven't really found them honestly useful for what I bought them for. I bought them to try to get into like tight spaces, but I've been pleasantly surprised at how good they are at just wiping up like a lot of flux on the board. As you can see already, the board is pretty clean from all that flux just from one of these. And we can also apply a little bit of heat while cleaning with the hot air. Just low temperature, nothing too hot, like 160, and just get everything clean. The way I like to use these is just grab some blunt tweezers, and don't grab it like all the way down like this. I like to grab it up at the top. Squeeze it, dip it in alcohol, and unsqueeze like this to get it really soaked with some alcohol. Then we can come over to the board. We can heat the area with some low temperature hot air just to melt the remaining flux on the board there, and then just dab it on the area that you're trying to clean. And the reason I recommend grabbing up towards the top of the sponge is so you're not scraping accidentally the PCB with your tweezers. Cool, and look at that, the entire board is just super clean. So I'm actually going to wait to put that cap on there that's missing until after I have the port on, because it's just going to get in our way. But I will tin the area, so we're just going to add a little flux to the pads here, and we can go over it with some leaded solder like this, and just make sure I get some on the capacitor pads there. Come on, I accidentally got some in the ground hole there, trying to get this cap pad. Come on, there we go, that's fine. All right, so now we just need to grab a new port here. So here's the new one, and we're going to throw it on to the board here. The nice part about clearing these ground holes first is you can just throw the port on and test fit it, and we can angle the microscope here, zoom in, just make sure it's sitting nicely on top of the pads. Cool, just like that. That is perfect. So I'm just gonna leave that flux on there, and we can come over here, hang it off of the table again, and same thing, no nozzle. We're gonna go up to 400 max airspeed and take some blunt tweezers and test how you're gonna press down on the HDMI port. We're gonna wanna apply some pressure while the solder is liquefied, and we want to apply the pressure towards the back of the port here, not on the front, because it's going to push it forwards. So we're just going to slowly heat up both sides here, and we want the pins on the HDMI port, the pads on the board, and the solder all to reach a good enough temperature to make a solid joint, which is why I'm heating from the bottom and from the top, not just from the top. The board is thick, and those ground pads especially, which there are quite a few of on the HDMI port, they all need to be up to temperature. So at the end here, I'm just going to make sure the port is lined up nicely, and then we're just going to press down on here while applying heat from the top at the back of the port right above the pins, and then just let the heat go. Keep your pressure on the port, try not to move it, and the solder should solidify. Alright, let's inspect under the microscope how everything looks, and we can tap each of these to make sure they're actually soldered to their respective pads, and they are. You can see none of these are moving when I apply a little bit of pressure. That means they are properly soldered to their pads. But what we can do is come in here, we can add a tiny bit of fresh flux, and I'm going to tin my iron a tiny bit, and we're going to come in and tap each of these on the top just to make sure the solder really covers each of the pins. And I'm just using 400 on my iron, but just tapping it. Like, you don't need to keep your iron there for very long at all, and it's best to do this when the board is preheated right after you put the port on. So this is great. You can see all those are shiny and they're not going anywhere. We applied a lot more solder than the factory applied. None of them are moving around like before, so I'm pretty happy with that. Those are all looking really great. So let me just get this cleaned up. Again, I'm just going to come in and hit this with some low temperature hot air, and I'm going to use another foam cube since there's quite a lot of flux in there, and we just want to clean as much of it out as we can. I'm not going to go too crazy with cleaning. I'm mostly just going to clean around the pins. Cool. We can use the hot air to melt everything. All right, and now let's flip the board, and I'm just popping some flux on these ground holes here. Again, I'm going to come in with the larger Hakko iron, and we want to really add quite a bit of solder to these holes. So just add a bunch like that. Keep the iron on and come in with like 370 on the hot air station, and just really get that to flow through the entire board, not just the back of the board there. It's going to kind of pull a lot of that solder down into the board, which is exactly what we want. And we'll do the same thing on this side. Just add a lot of solder and use some hot air. Cool, that's perfect. And same thing, same exact thing. And do what you can to not drip flux down into the port, because you don't want flux on the pins inside the HDMI port, and flux is non-conductive. Next, I'm going to throw down a clean room wipe like this, and we're going to just heat the port with some low temperature hot air again. Just the inside of the port too, and behind the port. Just really get the entire port warmed up. And then we're going to come in and flush out any remaining flux with some alcohol like this, because we don't want any flux in the port. Flux is non-conductive, which is great for soldering purposes, but it's not good when it's in a port. So we don't want any of that flux inside of your HDMI port. I'm just going to do this a couple different times. We can see mostly, like on the front pin right there, the solder came through to the other side because we used the hot air. You can see on both of those front pins we're good, but the back pins here could use a little bit of extra solder. So I will just add a tiny bit of flux there, and we can add some solder to these front pins. Again, we can use some hot air to help us out. Cool, so that is looking better. And we can do the same thing over here. Same deal on this side. Cool, that is looking good. All right, so I've got another PS5 board here, and I'm just going to snag that capacitor from right there. So let's just grab that, and let's pop this down into the flux. I'm just going to grab the capacitor and line it up, add some flux. We're going to use the conical tip on my iron, and now I'm just going to heat. Cool, so we got one side there. Then we can try to add some solder to the other side. Here's where some thin soldering wire can help here. Perfect. And now we can melt it with some hot air. Perfect, and that cap is nicely in place. So now we can clean the board. Also just gonna snag this little bit of solder that was on top of that component there, and we can get this thing cleaned up. So that capacitor isn't strictly necessary for the HDMI to work. However, I have heard that a missing cap there can impact 4K resolution on certain TVs, and we obviously want to give the customer full functionality of their console. So we do still want to replace that cap when it's missing. So that is a beautiful looking HDMI port replacement. The port is nicely anchored. It's not moving around anymore like before. And all the pins there have sufficient solder on them. So we are very happy with this. The last thing we need to address is this big oxidation spot on the APU. So for this, just take a dry Q-tip, and we're going to grab all of the liquid metal on the outside here and kind of try to bring it onto the die. You really do want to try to use a nicely compacted Q-tip like the one I have here. You can also use these black Q-tips that the applicator comes with. These are just like essentially nicely compacted Q-tips. And the idea here is to put sufficient pressure on the die to get that nice and shiny. So right now you can see none of the liquid metal is sticking to this, and that's because there's all of that oxidation on there. So you really have to press pretty hard actually for that oxidation to come off. This is actually quite a bit of oxidation. You can also use some alcohol, and eventually it makes this horrible sound, but this is good because you can see the liquid metal is starting to adhere. So we can see the liquid metal is now finally adhering to the die, which is what we're looking for. All right, I just did the same thing for the heatsink here, and you just want to make it all shiny. Don't give up. It takes some time sometimes. And then once you're done, just soak a Q-tip and alcohol and come around the outside, and the alcohol kind of pushes away the liquid metal, and you can group it all back up, and it will just sort of like pull itself onto the heatsink or the die of the APU if you're doing the motherboard. So you just want a lot of that to get back onto the heatsink or the die, and then we can come in and just sort of clean up around any excess. Cool, so that's looking good, and let's get this console back together to test. Now we can get this thing tested. Just gonna plug in power and HDMI here, and we can look at this screen here to make sure it works. So I just turn it on, and we're looking good. We've got display, good stuff. PS5 is functional. It's gonna get this thing turned off, and we will get it reassembled. And you do not need to put one of these metal screws in every single hole here. There are a few where you do not need to put one. Those screws will be marked with a slash through them like this. So don't put these screws in on here yet, because these are holes for screws that we put in later on when the console is further reassembled. Good stuff. So we've got a working PS5 assembled now. We can't forget the little grill here, and then we can throw our covers back on. Man, these covers are beat up. Cool, good stuff. So we've got a working PS5 now. I'm gonna get this back to the customer. I hope that was a helpful video for anyone doing this for the first time. I appreciate you guys for watching, and I will see you in the next video. Peace.